Hi everyone, today we'll be taking a look at question 279 on LeetCode called perfect squares. So the idea is given a positive integer n, we want to find the least number of perfect square numbers which sum up to n. So in the example of 12, the least number is 3 using 4, 4, and 4. So this is going to be a dynamic programming question once again because we're choosing which perfect squares we want. And the idea of this question is actually really similar to another question called coin change, which I already have up here. If you're unfamiliar with how coin change works, please refer to that question because I won't be explaining some of the intermediary ideas in between. But instead, I'll be adjusting the code just to make it work for this one. So we can think of the amount of change that we were making coin change as the positive integer n that we're making here. So this would be new array n plus 1 dot fill infinity because we're assuming that every number has an infinite number of square numbers that we're going to be comparing with the new min and updating henceforth. Now, dp0 equals 0 is our base case. This is still true for this question. Why? Because we can't use 0 as a perfect square. So if I had n equals 0, it would just be 0 because there's no possible perfect squares that make it. Then we iterate, so I goes 1 to n. And what are our coins in this case? Well, our coins in this case are any possible perfect squares up to the value I that we're iterating to. So we can say let j equals 0. And to use the idea of perfect squares, we can say that a perfect square can be j times j is less than equal to I, aka the square root of j is the perfect square that can fit into I. J plus. We don't need this statement anymore because we're guaranteeing from this statement here that j is always going to be less than I. Oops, that looked weird. And once again, the coin in this case is the perfect square. So in this case, perfect square once again is just j times j. And at the end, we don't need to compare anything. We just have to say dp of n for the last value. So once again, the idea behind this is we're going to iterate through every single possible value. The quote-unquote coins in this case is going to be j, which will represent every perfect square up to I. And everything else is pretty much the same. We're going to be updating the min number of perfect squares needed every single time we iterate. And that's about it. So with that, let's see if this works. Works just fine, and works just fine, runtime wise. This is still O of n, but since we're iterating up to the square root of that certain value that we're iterating up to, this is O of n times O of n to the 0.5. Because once again, this is going only up to the square root of I. So in total, we can actually just summarize this as O of n to the 1.5, or 3 over 2. Runtime, where n is given input. So with that, I'll put a link to the question as well as my GitHub down below. I also mentioned in the comments that this is a very similar question to coin change, and I put a link to that as well as if you want to take a look at that. And I'll see you guys next time.